As we discussed about the way of finding limits if the result is an indeterminate form. See, when you replace direct value of x in the function, if the result is an indeterminate form, then to avoid that indeterminate form, we need to use different skills. Algebraic skill, geometric skill, calculus skill, or your logical skill, anything, okay? And when coming to algebra, basically we have three different logics related to algebra. Either we may use factorization or rationalization or simplification to avoid indeterminate form. Okay. So if you have any confusion or any issue related to that indeterminate forms, you just revise previous class. Okay. And now in this class, using that algebraic methods of factorization, I am going to generalize, I am going to give you a formula which we consider as a standard limit. Okay. So initially I will give you different formulas just like problems, and we will analyze everything, and at the end of all these concepts I will make a list of all standard limits. Okay. First of all, you just look at this first one. Limit x tends to 7 x cube minus 7 cube by x minus 7. So directly if you substitute 7 in the place of x, what will happen? See, direct substitution, what it makes and then what we need to do. When you substitute directly 7 cube minus 7 cube divided by 7 minus 7. Direct way is substituting 7 in the place of x. So this is equals to 0 by 0. And we know that 0 by 0 is an indeterminate form. So see, if you have your answer as an indeterminate form, that in a sense something wrong is happened. Okay. So to avoid that, we need to use factorization again. Limit x tends to 7. The numerator is this x cube minus 7 cube. So see, if you observe that x cube minus 7 cube, yeah, that x cube minus 7 cube is of the format a cube minus b cube, which can be written as a minus b. X minus 7 into x square plus 7x plus 7 square and divided by x minus 7. And now if you cancel out this x minus 7, limit x tends to 7, this x square plus 7x plus 7 square. Now if you replace x with 7, 7 square plus 7 into 7 plus 7 square. Now nothing is wrong because it is a determinate value. 7 square, 7 square, 7 square. Totally how many 7 squares are there? 3 7 squares. And you can calculate its value, 49 threes. But I need this format actually. Once look at the problem, which is limit x tends to 7 x cube minus 7 cube by x minus 7. And we found its value as, see, this power 3 into 7 to the power this power minus 1. Okay. See, at the end after this algebraic simplification, we have its answer as 3 into 7 square. This 3 into 7 square as a general format if you observe. That general format is simply nothing but power into this 7 to the power 3 minus 1. And I will give you the general form with the discussion of bit b. Okay. First of all, for bit a, you just look here. If you directly substitute, then you have an indeterminate form. To avoid it, go for factorization. And on factorization, your answer is 3 into 7 square. I think everything is clear. So now, see what to say about the second problem. Limit x tends to a, x power n minus a power n by x minus a. And I mentioned you here that n is a natural number. Just like this power 3 is, okay. Just to compare the second bit with the first one. Here a value is what? 7. Here n value is what? 3. So that n if natural, what will happen? That power n, if it is not natural, if it is like a rational, so what will happen? See, you will get that idea from C. If that power n, if it is not natural, if it is a negative integer, what will happen? That idea you will get from D. Okay. So I have different problems. Every problem has its importance. Okay. See, first of all, I am going to discuss bit B. When you pay attention on this bit B, yeah, limit x tends to a, x power n minus a power n by x minus a. So usually the first thing is substituting x as a in that. If you substitute x as a in it, what will happen? A power n minus a power n by a minus a. Is it right? I am not mentioning. Okay. I think it is clear. So when you substitute x as a, you will get again an indeterminate form, 0 by 0. So to avoid it, what we need to do? Again, we need to go with any one of the algebraic scheme. Okay. So for you, just look here. When you substitute directly a power n minus a power n divided by a minus a, this is equals to 0 by 0. That 0 by 0 is an indeterminate form. So don't accept it. To avoid that, you need to go with any algebraic scheme. So here limit x tends to a. The numerator is what? X power n minus a power n divided by x minus a. So this is equals to limit x tends to a. Think about the numerator. X power n minus a power n. Just like as we factorized for x minus 7 cube, here we need to factorize this x power n minus a power n. So we have a specific factorization for this x power n minus a power n. Okay. If you don't know that factorization, you just divide the numerator with the denominator with the division of polynomials. So in any way, you can realize that this x power n minus a power n is simply nothing but x minus a into x power n minus 1 plus x power n minus 2 into a plus, continuously the x powers will get decreased, and as well the continuously the powers of a will get increased. Okay, x power n minus 3 into a square plus and so on, plus at the end you will get that a power n minus 1. Okay, just look there. This x minus a into this total expression, the product of these two is simply x power n minus a power n. Okay, if you wish, go for a verification. I think you know the way of multiplying two polynomials. So with the usual multiplication technique, if you multiply these two, you will reach this x power n minus a power n. So at the end I will conclude that the numerator x power n minus a power n is simply x minus a into this. Okay, and now you can cancel this x minus a. Hence we left with this x power n minus 1 plus x power n minus 2 into a square plus, like that if you continue, powers of a will get increased for term by term, as well powers of x will get decreased from term to term. So now we need to replace x with a in this. When you replace, what will happen? If you replace x with a, the first one is a power n minus 1, replacing x with a, plus what is the second term? Second term will become like this, a power n minus 2 into a. Then what will become the third term? A power n minus 3 into a square. So like that if you continue, the last term is again a power n minus 1. See, from this x power n minus 1, if you replace x with a, the first one is a power n minus 1. The second one is what? A power n minus 2 into a square. See, once think about it. What is this a power n minus 2 into a? See, that a power n minus 2 into a is again a power n minus 1, because we know the multiplication of two exponents. If you multiply these two, we need to add the powers. This power is n minus 2, this power is 1. This is again what? A power n minus 1 only. This is a power n minus 1, this is a power n minus 1, this is a power n minus 1. Everything is a power n minus 1. So a power n minus 1 plus a power n minus 1 plus and so on plus a power n minus 1 for n times. So see, limit x tends to a, x power n minus a power n by x minus a is simply nothing but adding a power n minus 1 for n times. So adding the same quantity for n times is simply nothing but n into a power n minus 1. At the end we conclude that this limit x power n minus a power n by x minus a, the answer for this problem is n into a power n minus 1. This power n into this value a to the power n minus 1 is the general format if n is natural number. Okay, see, the proof is correct, the proof is acceptable if n is a natural number. If n is not natural, what will happen? If n is not natural, then also the result is acceptable, but the proof is little bit different. But without mentioning the proof, I will give you some problems, okay? To generalize this statement is acceptable for everything, okay? So first of all, limit x tends to a, x power n minus a power n by x minus a is n times the a power n minus 1 if n is natural. Once again, now you just solve the first problem. When you compare the first problem with the second one, what you say? The value of n is 3, whereas the value of a is 7. after identifying n and 7, use this particular formula n, which means 3 into a means 7 to the power 3 minus 1, and that is equals to 3 into 7 square. So now it is very simple with this bit b to solve the problems like first one without going with the usual factorization. So at the end you need to memorize, you need to identify every time that if the function is of the format this x power n minus a power n by x minus a, then its limit value is directly n into a power n minus 1. Okay, that's it. Have a look. Now we have a formula, okay, this as a standard limit. Now we need to solve c bit. When you think about that c bit, it is given like this: limit x tends to 5. See, fourth root of x. Fourth root of x can be written as x power 1 by 4 minus, this is what, fourth root of 5, which can be written as 5 power 1 by 4 divided by x minus 5. Okay. Now when you look at the pattern, when you look at the format of the problem, this is limit x tends to 5, x power 1 by 4 minus 5 power 1 by 4 by x minus 5. This is as in the same format of this b bit, but as we mentioned here, n is a natural number, but here that power n is not natural. So we don't have any reason or proof to use the same formula for this. Okay, so that's why to make a reason, to make a conclusion on this, I am mentioning this problem here. So to solve it, what I do is, first of all, you just let limit, see, not limit, you just let x power 1 by 4 as some y. See, this is x power 1 by 4, just take it as y. And the number is there, what is that? 5 power 1 by 4. You just take that number as b. Let x power 1 by 4 as y and y power 5 power 1 by 4 as b. Then what will happen? Then x will become y power 4 and 5 will become b power 4. Is there anything wrong? Nothing. Okay. Just I consider these two as y and b, and that x is equals to y power 4 and 5 is equals to b power 4. Replace the problem. As x is tending to 5. Okay, to replace, I need to think like this: as x is tending to 5. X means what? X means y power 4. Okay. So as x is tending to 5, from this it is clear that y power 4 is tending to 5. See, y power 4 is tending to 5. What we need to do? Y is tending to 5 power 1 by 4. As y is tending to 5 power 1 by 4, that 5 power 1 by 4 is simply b, so y is tending to b. So as x is tending to 5, y is tending to b, that y and b are, see, y and b are our requirements actually. To solve the problem, just I consider this x power 1 by 4 as y and that 5 power 1 by 4 as b. Okay. Now what will happen? Now when you rewrite the problem in terms of y and b, the problem will become like this: as x tends to 5, y tends to b. So I will replace x tends to 5 with y tends to b. And this x power 1 by 4 as y, 5 power 1 by 4 as b, and the denominator x as y power 4, and it is minus 5 power b. Okay? Yeah. Not 5 power b, 5 is right, and that is b power 4. This is 5, can be written as b power 4. So the given problem is simply nothing but the same one. Given problem is in terms of x and 5, and that newly framed problem is in terms of y and b. These two are same with this particular substitution: x power 1 by 4 as y and 5 power 1 by 4 as b. Now we need to solve this. Limit y tends to b by b, y minus b by y power 4 minus b power 4. By the algebra of limits, I can rewrite it like this: 1 divided by limit y tends to b, y power 4 minus b power 4 by y minus b. Just reciprocate and send the limit to the denominator. Okay? Right. Now limit y tends to b, y power 4 minus b power 4 by y minus b. Here the power 4 is clearly a natural. Now this formula is acceptable. So use it. Then it will become how? G. And here I am writing for the space. So this is equals to 1 by 4 into b to the power 4 minus 1. N into a to the power n minus 1. Here n is what? 4. And instead of this a, we have b. So 4 into b power 4 minus 1. Okay. Now how can I simplify? I will simplify it like this, 1 by 4, okay. This is equals to 1 by 4 into 4 minus 1 is 3, b power minus 3. But what is minus 3? B power minus 3, okay. But what is b actually? This b is actually 5 power 1 by 4. So this can be written as 1 by 4 into 5 power minus 3 by 4 as your answer. Just have a look. 1 by 4 into 5 power minus 3 by 4. See, once again if you look, the answer for the given problem is simply what? 1 by 4 into 5 power minus 3 by 4. And I will rewrite it in such a way, this is equals to 1 by 4 into 5 power 1 by 4 minus 1. Is there anything wrong? Is there anything wrong? Here the power is what? 1 by 4. So 1 by 4 into this base value a 5 into to the power n minus 1, 1 by 4 minus 1. That in the sense, if the power of that, okay, in that formula, if n is not natural, if n is a rational number, then only we have the same formula. Okay, if n is natural, this particular limit is n into a to the power n minus 1. If n is not natural, then also the answer is n into a to the power n minus 1. And similarly, we can prove the last one. If that power n is a negative integer, what will happen? Okay, just have a look, note it perfectly. This is just an example. This is just a explaining the way, explaining why the same formula is applicable for a rational number. The same formula is applicable for rational. The same formula is applicable for integers also. But to support that statement, I am just giving few examples here. That is C, and then I will discuss D. Okay, have a look. So what I am explaining is, see, this is the basic standard limit. Limit x tends to a, x power n minus a power n by x minus a is n into a to the power n minus 1. This formula is true for n natural, for n rational, for n integer. But the proof is different for natural, different for rational, different for integer. So I need to give you the proof in 3 different ways. But what I did is, I just mentioned you the general proof for the natural n. Whereas if n is not natural, if n is a fraction, just like this 1 by 4, here n is 1 by 4, a fraction, right? So then in this case, instead of giving the proof, I just solved the problem, and at the end I concluded that the same pattern is acceptable for its answer. As a part of solving, I need to convert the given problem again into this particular format. For that conversion, you just let this x power 1 by 4 as y, this 5 power 1 by 4 as b. Okay, right. And from there we did everything. So this is just a support to say that this formula is acceptable for rational n also. Okay, but every time it is not required to solve in such a manner. See, every time usually we just use this formula directly. But how it is useful for rational n? Answer for that question is this explanation. Okay, in a similar way, if n is not rational, not natural, if n is an integer, negative integer, if n is a negative integer, then how to accept the same formula? Here n is a negative integer. See, first of all, solve this problem with your usual way. At the end, the answer is for sure in the same format. Since the answer of this problem is again in the same format, now we are ready to accept that this formula is acceptable for integer also. Okay, that's my discussion. So to support that, again try to solve the problem. How can we solve this d bit? Just have a look. See, again to solve d bit, first of all, the problem is in terms of x, and to solve it, I will convert it into in terms of some other variable. You may say it as some y. Limit x tends to 9, x power minus 7 minus 9 power minus 7 divided by x minus 9. Okay. So what I need to do? What is x power minus 7? Basically x power minus 7 is what? 1 by x power 7. Is it right? I do in this way, okay? Not with y, I do in another way. Limit x tends to 9. This is 1 by x power 7. minus 1 by 9 power 7. Okay. Divided by x minus 9. Okay. Is it right? And then just do, yeah, LCM. What will happen? Limit x tends to 9, 9 power 7 minus x power 7 divided by x power 7 into 9 power 7, and the whole thing is divided by x minus 9. As we learned the algebra of limits, easily you will apply limit for numerator, for denominator, for every term of the summation like that. So what I do is, see, I will common out minus from this numerator and I will attach for this. So ultimately it will become like this. Limit x tends to 9 minus 1 by x power 7 into 9 power 7 into x power 7 minus 9 power 7 divided by x minus 9. Just have a look. So x power 7 minus 9 power 7 by x minus 9. So one minus is different, one minus difference is there for these two. So just collect that minus and add for this 1 by x power 7 into 9 power 7. Now at the end, when you apply limit x tends to 9, this will become 9 power 7 into 9 power 7. Okay. And for this, directly if you apply 9, it is indeterminate form. So now you need to use the same formula, which is n into a to the power n minus 1. That n is what? The power 7. A is what? This 9. Okay. So at the end what I have is, from this one, our answer is minus 1 by 9 power 7 into 9 power 7. And for that term, see, n into, that in the sense 7 into 9 power 7 minus 1. Is it right? Is there anything wrong? Just think about it. So at the end, if you combine everything, this is 9 power 7 into 9 power 7 is 9 power 14. This is 9 power 6. You just try to simplify. Okay. I am using this space for the simplification. This is equals to minus 7 into 9 power 6 minus 14. That is equals to minus 7 into 9 power minus 8. I will rewrite it like this: minus 7 into 9 power minus 7 minus 1. So this is of the format n into a to the power n minus 1. So if n is a negative integer, then also at the end my answer is of the format this power minus 7 into this a 9 to the power that n minus 1. So at the end what I am concluding is, see, if the function is of this format and the n may be natural, may be rational, may be integer, for any real value of n, the answer must be just like n into a power n minus 1. We have a chance to prove it for irrationals also, okay, but no need to go with all those things. If you have an irrational, again let it as y, let it as b, like that we can prove, okay. But then you just memorize that, you just identify that this particular function as x tends to a has a limit of n into a to the power n minus 1, okay. Have a look. See, just observe everything, okay. Actually what I am going to tell you is, see, this formula is acceptable for all n. N is anything, you just use that formula. So, but to support my statement, I need to give you some explanation, right? So that explanation is these three examples. For n natural, the formula is acceptable. For n rational, the formula is acceptable. Why it is acceptable? I mentioned you the explanation without using this, but my answer is same. If n is integer, then also the formula is acceptable. How it is acceptable? If n is integer, first of all, see, if n is integer, first of all, you just solve in normal way. At the end, the final answer is again satisfying the same format. So, from this what I conclude you is, see, you just erase everything. Finally, you just memorize one thing, which is limit x tends to a, x power n minus a power n by x minus a is equals to n into a to the power n minus 1. Limit x tends to a, x power n minus a power n by x minus a is equals to n into a to the power n minus 1 is true for all n. Is true for all n. Okay, if you ask me how, my answer is different. For natural values of n, I need to give a separate explanation. For integral value of n, I need to give a separate explanation. For rationals, a separate proof. For irrationals, a separate proof. Okay. See, this is true for all n, but proving this standard limit is different for different range, different values of n. For natural n, integral n, rational n, irrational n, the proof part is different. Okay. So to give those proofs, just I mentioned two different examples, but at the end you just don't bother about everything. Just concentrate on this statement. For all n, this is acceptable. Okay. Okay. Just I will give you some problems which gives you some satisfaction for you. Limit x tends to 2. Something you say, yeah, x power 17 minus 2 power 17 divided by x minus 2. What is its answer? Just have a look for a minute. Limit, what I need to give? Anything, no problem. Yeah, first suppose limit t, it may be x, it may be t, no problem. Limit t tends to, anything you can take, minus 3. Limit t tends to minus 3. Okay. Limit t tends to minus 3, or suppose take it as limit t tends to 3, t power 4 by 5 minus 3 power 4 by 5 divided by t minus 3. What is your answer? Limit some z tends to 6, z to the power minus 19 minus 1 to the power minus 19 divided by z minus 1. What is your answer? In the same way, I can give you like this. Limit x tends to root 2 x to the power 6 minus root 2 to the power 6. Otherwise, what I just a minute. I will take that power. Okay. Limit x tends to 6 x to the power root 2 minus 6 to the power root 2 divided by x minus 6. What are the answers? Just observe all these things. Okay. The n is different from problem to problem. Here n is natural. Here n is rational. Here n is an integer. Here n is an irrational. For all these things, the formula is acceptable. Just to support that, I gave you different examples, but don't bother about it. What is the answer for this one? N into a to the power n minus 1. N is 17. What is a? This 2, this 2, this 2. Everything should be same, and that value is mentioned as a. 2 to the power 17 minus 1. So if you simplify it, 17 into 2 power 16 is your answer. Then coming to the next problem. What is your answer? See, t power 4 by 5 minus 3 power 4 by 5. Here n is 4 by 5. So n into 4 by 5 into a is the number same everywhere. Okay. A to the power n minus 1. So 4 by 5 minus 1. Directly we write this one. Okay, that's it. Whereas coming to this problem, again n into, what is n here? Minus 19 is n. Okay. And a is what? Oh, just a minute. I need to say here also 1 only. These three should be same. Okay. 1, 1, 1. A. So this a is 1 here, and 1 to the power n minus 1. N minus 1 means what? Minus 19 minus 1. Because of the space, I will mention here. Okay. Minus 19 into 1 to the power minus 19 minus 1. And say last problem. Here n is root 2. I will write it like this. N into root 2 into a is 6. A to the n into a to the power n minus 1. 6 to the power root 2 minus 1 is the answer. Okay. Just have a look at that. This formula is acceptable for all values of n. Okay. So if you face a problem, you just directly use that particular formula. Like n into a to the power n minus 1. Every time the explanation, the logic, the proof is not required. For first time, it requires. Okay. Have a look. So the same formula. Limit x tends to a, x power n minus a power n by x minus a is acceptable for all these things. Okay. First of all, this is directly in the same format. So here the value of power n is 11 and a is 3. So directly I will write the answer as 11 into 3 power 11 minus 1. 11 into 3 power 10 is the answer. But whereas for this problem, this is given as minus y to the tends to 5. So but usually I need to mention that x tends to a format. So I will rewrite it like this. Limit this minus y tends to 5 can be written as y tends to minus 5. No problem. Okay. And this is y plus 5, which I can written as y minus of minus 5 divided by y power n plus 5 power 9. So this is simply nothing but what? Y power 9 minus of minus 5 power 9. Just look there. Minus of minus 5 power 9 is simply y power 9 plus 5 power 9. So everything is same. So here what is our usual a? Usual a in the formula, limit x tends to a, x power n minus a power n by x minus a. Here a is simply minus 5. And as well it is of the reverse format, right? So I will rewrite it like this. This can be written as 1 divided by limit y tends to minus 5 y power n minus minus 5 to the power 9 divided by y minus of minus 5. Just reciprocal of the general format. So now this is equals to 1 divided by, here what is n? N is 9 and what is a? Minus 5 to the power 9 minus 1. This is your final answer. If you are comfortable, directly you can answer from here. No need to write this step. Okay? Or otherwise you just go to that step and then reach the answer like this. 1 by 9 into minus 5 to the power 9 minus 1. Is it right? Just have a look. I just identified that a value as minus 5 and n value as 9. Okay? Then think about the next problem. This is also very simple. Limit x tends to 1, x power 9 minus x power 8 by x power 1, x minus 1. X power 19 and x power 8. See, this x power 19 and x power 8 can be written as like this. This is equals to, okay, limit x tends to 1. You can common out x power 8. If you common out x power 8, it will become how much? X power 11, right? Okay, I will erase this and then I will tell you. So this is equals to limit x tends to 1. When you common out x power 8, this is x power 19. If you separate x power 8, you left with x power 11 minus 1 divided by x minus 1. As x is tending to 1, replace x1 here, which is 1 power 8 into. So this x power 11 minus 1 by x minus 1. This 1 also can be written as 1 power 11. So x power n minus a power n by x minus a. So this is simply nothing but 11 into 1 to the power 11 minus 1. And you will get your answer. At the end, this particular problem. Limit x tends to a, x power m minus a power m by x power n minus a power n. Okay. Always we need to search for the general format. X power n minus a power n by x minus a. If you search for it, we need to divide with x minus a. Okay. I will discuss that one. You need to memorize this one also as a separate formula, a standard limit. Limit x tends to a, x power m minus a power m divided by x power n minus. Just we need to find this particular value. So to find it, you just divide both numerator and denominator with x minus a. So to convert it into the usual format, limit x tends to a, x power m minus a power m divided by x minus a divided by x power n minus a power n divided by x minus a. That's it. And now you just apply limit for both numerator and denominator. When you apply limit for numerator, it becomes limit x tends to a, x power m minus a power m by x minus a. When you apply the limit for the denominator, it will become limit x tends to a, x power n minus a power n divided by x minus a. Now apply the same formula for numerator as well denominator. For numerator it is m into a power m minus 1. For denominator it is n into a power n minus 1. Further you just try to simplify. M and n, so m by n into a to the power, this if you send this to the numerator, it will become like m minus n. Use the loss of exponents. Okay? If you use the loss of exponents, at the end the answer is this. So finally, the answer for this particular problem is just nothing but m by n into a to the power m minus n. Okay? So just observe everything. Okay? And I will start next class with different examples of the same type, and then I move further to the other standard limits. Have a look.